Hey everyone. So what I want to do today is walk through, kind of talk you through one of the problems from yesterday. I think it's good that you kind of see something that you did yesterday, hear it again, and then I do want to get stuff down for you for the rest of today's classwork. So we're finding the surface area. And so surface area is kind of what it says. It's the area of the surface of a shape. So think wrapping paper in a way. Think about if you're going to color the outside of a shape there and how much area it would take up. So it's very similar in a way to what we were doing before, where we were chopping up a particular shape and then finding the area of each of those shapes. So for example here, in shape number one, hopefully you see a rectangle. Shape 2 is a rectangle, and shape 3 is also a rectangle. So to find the area of rectangle number 1, we can see that it is 8 wide, and we can see that it's 3 tall. So 8 times 3, and we get an answer of 24. Now, just because those rectangles look the same doesn't mean they are always going to be the same. In this particular case, when I go over to rectangle number 2, I can see opposite sides have the same length, so that's also an 8. And I can see it tells me that it's 3 tall as well. So it is going to be the exact same in this particular case. So 8 times 3, again, we're going to get 24. The third particular rectangle looks like it's missing a lot of information. I can see opposite sides is an 8. And now watch what's going on here. You see these marks? These marks let me know that all those sides are the same length. So this side's 3, this side's 3, this side's 3. What you're going to start to notice here is these L's that are going to appear. Anytime you have an L, the sides will always match up, because if you would fold it, they would match up with each other. So that tells me that this is also 3. So once again, we're also going to have an 8 times 3, and we're going to have 24. It leaves me now with the two triangles that are here. I can see that the base is 3, which means the base is 3. Again, I see in a rectangle here, so opposite sides are the same. I can see the height of that particular triangle is 2. Remember, we're looking for that right angle. So for the two triangles, which I will call region 4 and region 5, 4, 5 over there. It's going to be base times height, and then we divide it by 2. So 2 times 3, we get a 6. Oh, wait, but we have to divide it by 2 because it's a triangle. It gets cut in half, so it has an area of 3. Same thing that's going on here. These are the exact same. So 2 times 3, again, it's 6 divided by 2, and yes, we get a 3. So now what I gotta do is I gotta add everything up. So 24, 24, 24. All right. So let's see here. 4, 8, 12. Carry the 1. All right. 2, 4, 6 plus the 1 is a 7. So that's a 72. Over here, I've got a 6. So 72 plus 6, hello, 78. This is our triangular prism. And the reason why it's a triangular prism is because I see all the rectangles, which is what makes it a prism. Triangular because bases are both triangles. Okay, so let's get on into what we're seeing here today. So 4, 5, and 6. So I know it doesn't show up very well. We did make some comments there for you. Right here. All right, that's the guy we're after. This guy is an 8. So we're aware of it. So if we're matching up particular sides, um, there's one of those L's that we're talking about, right there. So these guys have to match up because that's where they're going to fold at. If they get folded, these sides would touch. So if that's 8, that makes this guy an 8. We know opposite sides in a rectangle have the exact same, which makes this guy an 8. And again, we can see that L that is formed. So again, if this is an 8, this guy needs to be an 8 as well too. Opposite sides rectangles are 12, so that's a 12, that's a 12, that's a 12. And again, we can fill in these to help ourselves out. It's not a requirement by law, but it certainly helps out. There's a 6, opposite sides a 6. All right, opposite sides a 6, opposite sides a 6. So now we just got some rectangles here. So I'm going to call you region 1, you region 2, you region 3, you region 4. My hand didn't come out very well, now did it? You're going to be region 5. You're going to be region number 6. Can I do better there? Does it show up? No, not really. Not really. Okay, all right. So in region number 1, I can see that we are 12 wide and we are 8 tall. So that's going to be a 12 times an 8. In region 2, I can see again we're 12 wide, but now we're 6 tall. That'll be a 12 times 6. Region 3, I am 12 wide and I'm 8 tall. So that's going to be a 12 times an 8. In region 4, again, we're 12 wide and we are 6 tall. So that's going to be a 12 times 6. Now here's the thing. In your rectangular prisms, you'll always have pairs. The top is always going to be the same as the bottom. The left is going to be the same as the right. And the front is always going to be the same as the back. So seeing pairs show up is something that's good. In a triangular prism, we're not going to have all those pairs. So don't be looking for them there. But a rectangular prism, which we have here, we do. And then I've got region number 5. All right. This is 6 tall, 8 wide. So 6 times 8. Region number 6 is this exact same thing. I know I got a 6 there, but remember it was region number 6 that we're looking at. So you can see we're 6 tall. If we wanted to, this 8 would match up. There's your L again. So again, we know that line is an 8. So again, 6 times 8. So yeah, now we're just multiplying away and adding them on up there. So hello 96. So you're 96 as well. You're a 72. All right. Makes you also a 72. 6 times 8 is 48. So I got a 48. And same thing that's going on here, 48. So we're just going to add all those guys up. All right. You've got a calculator. You can punch that in. All right. Trust me, really, you don't want to watch me add. All right. So in question number 5 here, this is that triangular prism that we kind of did in the previous problem. So what we do want to again notice here is that it's kind of not as good as an L, but it is a triangle. That's why it's matching up. Makes this guy a 7, which means because of these marks, that tells me all sides are the same. So you're a 7, and then you're a 7 as well too. Which means if you're a 7, you're a 7. All right. Because it's a triangular prism, those two triangles will be the exact same because in the top and the bottom of a prism are always the exact same that are there. So yeah, if we want to kind of go through it, we can see in region number 1 that's there, it is going to be 7 times 7, right? In region number 2, again, it also is going to be 7 times 7. I can see my 7 that's there. Again, I can see we're 7 tall, so there we go. And then in region number 3, all right, again, it's going to be the exact same 7 times 7 because, again, we are 7 wide, we are 7 tall. And then we've got our 2 triangles that are there. So remember, it's base times height. There's my right angle symbol, so I can see there and there. So there's my 4 and there's my 7. So for the last 2 regions, we'll call 4 and 5. It is a 4 times 7. Wait, it's a triangle though. It's a triangle. It's a trap. All right, yeah, we got divided by each of them by 2. So do make sure that you end up taking care of that. So hello 49. Hello 49. Welcome aboard 49. 28, half of 28, 14, and you're the same thing as well. You're also 14. Again, we can add all of those up, and we're going to get to our total surface area. All right, one more here that we're going to look at. Okay, so check this out. L's. Look at the L's. There's the 6. There's the 6. You have to be 6. We also know that opposite sides in rectangles are the same length. So if you're a 4, you're a 4. You're a 4, you're a 4, and if you're a 4, you're a 4. If you're a 6, opposite side is also 6. Hello, L shape, that's there. So you're a 6. Now, oh my goodness, watch what's going to happen here. Watch what we're doing here. All right, now, one of the things is this is where your visualization comes into play, and this is where it's frustrating for some of you because, again, visualization is not always the easiest thing to do. But if we would fold this 4, if we would fold it up, it would match up with that side that's there. All right. Now, if you're ever unsure about this, again, we know it is a rectangular prism, which means we're going to have pairs. All right. So we're going to have double dates all over the place. So again, top, bottom, same. Left, right, same. Front, back, same. So we will see those pairs. And if we kind of go through this and we're looking at our rectangles, that's rectangle 1, that's rectangle 2, rectangle 3, rectangle 4. All right. What you'll start to notice here, if you're unsure about rectangle 1, okay, if you don't see it, hold off on it for a second. Watch what I'm going to do here. Rectangle 2. We saw that clear. All right. We see it's 10 wide. We see it's 6 tall. So there's a 10 times a 6. All right. Rectangle 3. Again, we can see better. It's 4 tall. It's 10 wide. So again, 10 times 4. And again, we could see this guy better that it was 6 tall. It was 10 across, again, because of all those 10s. So again, we're seeing that there's a 10 times 6. So right now, you kind of see the one who doesn't have the pairs at 10 times 4. Come on over here for region number 5 and region number 6. All right, we can see we are 6 wide, 4 tall, 6 times 4. All right, again, your 6 and your 4 opposite sides are the same, and you can see there's your L that's formed. So again, 6 times 4. So the only one who doesn't have a dancing partner is at 10 times 4. And again, we did know that from the beginning. We did talk about that. But again, now I've got confidence that goes along with it. So there's a 40, another 40. Dancing partner. 60, also with a 60 dancing partner. 6 times 4 is 24. All right. And there's the dancing partner. That's there. So we'll add up all of those. All right. In fact, we can do this real quick. Oh, look at this. 100. 100, so we're at 200. That's a 48. So we've got ourselves our 248 meters. And it should be squared because remember, area is how many squares fit into a particular shape. So yeah, all right, visualization. That's really what we're after right here. We're going to see more surface area, but typically we deal with them when they are a three-dimensional shape, and that's more straightforward. And that's usually how you're going to see them. This particular lesson was working on your visual spatial skills. So if you did find it frustrating, it's okay. It's normal. It's typical. All right. We all don't visualize very well. Those of you that have played the cubes in the classroom, some of you are strong visual learners. You've heard me say this over and over again. Others of you, man, you're still working on trying to get that first cube, and that's okay. It's just that you're not as strong of a visual person that's there. When we leave Costco and we've got that huge cart that's full, all right, it's not Mrs. Susevich that's loading up the trunk. She does not have the visual spatial skills to figure out how to get all those groceries into the trunk. And oh, by the way, we still got to get the kids in the car. I do. All right. So that's why Mr. Savage gets in the car. All right. We turn the car on and I go ahead and I load it up because I can see how we can fit everything in. So again, visual spatial skills, a good skill to have. All right. Take care, everyone.